Welcome to another session of Code Unboxed. Today we're going to be going through Libgit2, and I'm joined by one of our expert analysts, Clement.
Hi,
with that,
glad to be here.
Thank you, Clement. As always, looking forward to conversation with you. As we've changed up the format a little bit, so today we're going to more be discussing the analysis of Libgit2. So let's get right into it. Before we do, as always, we like just to share our disclosure policy here at TrustInSoft. So we do take disclosure of vulnerabilities and bugs seriously. We follow a 90-day disclosure policy. So any software that we're talking about with any vulnerabilities or bugs that we're disclosing on this Code Unboxed show, we do have a 90-day disclosure policy with the software owner, and we do give them the opportunity to work with them as well to address any of the respective bugs. A 30-day reminder is sent, and then also oftentimes the software owner does address some of the bugs that we've already that we're going to be disclosing in the respective Code Unboxed show. So with that, I'm going to hand over to Clement to talk a little bit about Libgit2 and then also share some of his results, and we can have a conversation about it. Clement?
Thank you, Gavin. So yeah, Libgit2, that's an implementation of the Git versioning system, the popular versioning system. You've likely used the command line tool, but this project is actually a library that's distinct from the command line tool, which allows people to develop applications that can interact with Git repositories directly without having to rely on the command line tool. So for example, GitHub Desktop uses Libgit2. So yeah, we have done an analysis of Libgit2, and we have found 3 issues with in Libgit2. So I will share the project manager. So the first issue, the first 2 actually issues we found were null pointed references. Let me show that in the root cause investigator. So yeah, at this point, for example, here in the function filter def set attributes, we find that scan is being dereferenced, but it can also be null. And I can use the root cause investigator to look at where scan got this value, and I can see that it got this value a little bit earlier from a field in fdef, and I can navigate through the code and see it comes from this git str detach that can indeed return null. So the analyzer is correct in that assessment that null is a valid value by that point. If we look at why, we see that there's a possibility that we ask for a buffer of size 0, or that we are out of memory after a call to realloc. So again, those are real possibilities of the code. The second issue we found is very much the same. We have a pointer that can be null before it gets dereferenced. And if we look as to where that pointer comes from, it's again a call to malloc. Malloc can fail if the system is out of memory. So the analyzer is able to detect that we could have a null pointer reference at this point. And that's really interesting because, well, I mean, null pointer reference, not really a high target for like hacking, things like that, not much of a security target, especially on a modern system that would be running, where you're running Git, where null pointer reference, that's a seg fault, that's your application is crashing. If we're out of memories, the application cannot do much anyways. But it's still nice that, you know, using the analyzer and the root cause investigator, we can very easily track down where those bugs can happen and why they can occur. So yeah, it's very nice that we can find those kind of painful bugs as a developer. You know how painful null pointer reference can get. So yeah, the analyzer really helps you in finding out where those bugs come from. Now, the third bug that we found in get entry is slightly more involved. So again, let me show you that in the root cause investigator. So we are in this function get entry in config.c. So we are trying to get a configuration entry from the various configuration files that Git is managing. And we find here, so this is the part of the code where we did find an entry, and so we are copying it into the out buffer that was passed by the caller. And so we see the check here is that we enter that if the error that was returned by the get call just before is different from git error not found. So if the error is not that it's not found, we figure that there is data that we can copy. But that's not exactly true. We find that the another things that at this point you could have initialized data. And indeed, the result, we find that it's not only, so -3 would be error not found, but there's also the generic git error, which has value -1, which is possible. And here it was a little bit more involved. I had to kind of go a little bit deeper with the root cause investigator, but I did find that it was possible indeed to get the error code -1, so git error, at this stage, if we have a file system error. So when trying to read the configuration file, which we get an error in accessing the file or during reading of the file. Or it could also happen if the hashing subsystem has an error. So again, Libgit2 relies on hashes to check if files need to be cached or can need to be reparsed. And that subsystem can fail. And so in case of hashing error, you also have this generic git error, which triggers an issue at this stage.
So, Clement, I have a question, but before we go there, I'd like to take the opportunity just to explain quickly what TrustInSoft does. So what does TrustInSoft do at a high level? We empower developers to deliver mathematically proven zero defect software. What exactly does that mean? We offer both a code analyzer that somebody can use and perform the analysis. As you're seeing, Clement, the results of the analysis that Clement has performed using our code analyzer, or we do have services where our analyst team, folks like Clement, can do the analysis on your behalf. The difference, though, is excuse me. The difference, though, is we're applying formal methods to the analysis, and that gives some additional benefits. One, from a depth perspective, it enables you to find 100% of the vulnerabilities and flaws. Now, there's a caveat there. We focus on C and C++ code specifically, and then most recently Rust. Rust services is provided via our services offering. Somebody who's using our code analyzer on their own does not have Rust support yet. That will be coming later this year. And then secondly, you can do generalization of inputs. I know we didn't really talk about that today, but if you want to find out a little bit more information on that, you can just click on the link below to contact us and we'll go through that. That's really where you, through generalization of inputs, you can evaluate billions of tests really in one run. And then third but not least is because we're applying formal methods, we can mathematically guarantee that if we say that the software does not have any bugs, we mathematically guarantee the safety and the security of that respective software because there are no bugs. Right, let's go back to the overview that Clement is providing on Libgit2. How likely are these errors to occur?
So file system error, when you hear file system error, in the modern day, you need to think really network error. Because we all have network file system, we all have shared systems across multiple machines, and network errors can really be caused by anything, you know, a denial of service or anything. So that's something that can be controlled by an attacker, and really you can't really claim that you have control over file system errors, especially in the modern world. And the same thing with the hashing subsystem, even though it's unlikely that the hashing system would have an error. You need to think back. We had the XZ attack recently, the supply chain attack, where OpenSSL was OpenSSH actually got attacked. It's not out of the picture that you would have your hashing subsystem behave a little bit differently than what you're used to.
Mm-hmm. Okay. Thank you for that explanation. And then also, what are the consequences? You talked about OpenSSH. Obviously, I think everybody's quite familiar with that, but do you have any other examples of some consequences of these bugs?
So here, sadly, I do not. Libgit2 is just a library. The idea would be that it's embedded inside of some bigger application. And so here we find that it's possible, depending on when an attack is triggered, what the code did before, and so on. It's possible to pass some data, maybe attacker controlled, to some unsuspecting code. But we can't really tell about the consequences of that because we do not know what happened before that call to get entry, and we don't know what will happen after that call to get entry without taking a look at the bigger application. So that will 100% depend on the application that is built around Libgit2, and I can't really say about the actual consequences that would have happened in the wild.
Okay, thanks. Well, thank you. That was a good overview and explanation of the bugs that you found in Libgit2. If you want to find out more, or if you want to take advantage of the TrustInSoft code analyzer, click on the link below and contact us, and we'd be happy to set up a demo. As always, thank you, Clement, for the detailed analysis and explanation of the analysis that you went through. Until next time.
Bye.